Most people think RAG means upload a PDF and ask questions. That's wrong and that is misleading, which is why many apps fail. In this video, I will show you what RAG actually is, why it exists, and how to build a minimal but correct RAG pipeline using LangChain and Gemini. Now let's see what problems RAGs solve. See, what happens is that your LLM is frozen in training time. The amount of data and the time period of data on which you are going to train your LLM is fixed. That won't change, which is why LLMs sometimes hallucinate very confidently. Like it will force you to accept his or its a solution. And third thing, they can't access your private data. For example, if you want to add some context or you want to add something new, you won't be able to add directly. So that's why RAG is not about chatting with PDFs. It's about taking the knowledge from the PDF and using that knowledge in combination with your LLM to generate a proper output which is more correct and which will prevent LLM from hallucination. Now, why your PDF Q&A thing is a misleading thing? Because what happens is that most of the people, what they do, they dump entire document into the context. Now, if you don't know about LLMs, there is a concept called context window, and context windows are limited. It's not like an infinite resource, they are limited, and if you fill the context window, that's it. You can't add more context, or you can say more additional knowledge to the LLM. That's the only piece of knowledge LLM is going to look. There is no retrieval logic because obviously you have put whole document into it and it is going to work only for your tiny files. Now answer this question to yourself: if your document is small and your RAG works, is it built for all the PDFs or only for the small documents? The answer is no. It is not built for your all PDFs. It is only built for the particular document, and that's not RAG. You just built a demo and you just named it RAG. It is not RAG. Whenever you're building a RAG model, make sure you follow this structure. First, the user will enter their questions, then, a retriever will be there which will search the knowledge base. This can be multiple PDFs or any type of document you have uploaded or you have made available for your system. Then, from all the documents or all the knowledge graph, it will check the relevant chunks. That okay, this chunk is relevant to the question, this is valid, this you can leave. Then all the collected relevant chunks, they will go to LLM, and then a grounded answer, or you can say an answer which is based in the context, will come to you. So this is the thing. RAG is not a feature, it's a pipeline. So follow it like a pipeline, not like a feature. Now let's move on to the code. So these are all the dependencies, and I have provided you with requirements.txt file. So you can use it directly. Then I'm loading the environment variables. Here is only one environment variable, which is Gemini API key. Then I have created some sample documents. You can replace it with PDFs later. Then there is a splitter which will take every document and chunk it using this chunk size and chunk overlap. Then we will generate the chunks from the splitter. The splitter will take the documents and will generate chunks. After this, we need to change the chunks into embeddings, which your LLM can easily process. So for embeddings, I'm using Hugging Face sentence transformer embedding model. You can use any other model also. So different models will give you different embeddings, and which is okay. Then we will generate the vector store to store all these embeddings. So what will happen is that embeddings will take these chunks and store in the vector store, and your vector store will be persisted in your ragdb folder, this folder. So if this name doesn't make sense, don't worry. Then we will make the retriever. This is the most important thing. because what it will do is it will go into the vector store, it will study your query and check, okay, this is a relevant chunk, this is not a relevant chunk, and find the relevant chunks and decide what chunks should be given to your LLM and how many chunks should be given to your LLM. So this K decides that. Then your LLM, I'm using the Gemini 2.5 Flash model. You can use any other model also. And one thing, do make sure that your API key has this name. This is a non-negotiable. Your API key should be stored in a variable named Google underscore API underscore key. It will not change. Then I have given the prompt. I have passed the context and the question. Then we have a RAG chain, simple LCEL chain I have used. I'm passing the context, the question, the prompt, and then the LLM. And then I'm generating a response and I'm printing the result. So make sure that this part, this retriever part, you understand properly and what it is doing. See, retriever or retrieval will come always before your LLM. It is retrieval augmented generation. So first the retrieval will happen. It will help LLM to generate an output. So keep that in mind. And you can follow this process for any number of documents for however big your documents are. So keep that in mind. Now let's run this file. So it will take some time to run. And here you can see we have our output and exit code 0. So this, if you are seeing this, you can ignore it because what happens is that in LangChain and Hugging Face, sometimes there is a conflict between different models. So this is you can ignore. Now this is a real RAG. Retrieval is happening before generation. Now, why this architecture matters? This architecture matters because it is going to scale for large documents, it is going to reduce hallucinations, it will make the behavior of LLM explainable, and it highlights the concerns clearly. See, RAGs fail when your retrieval is weak, not when your LLM is bad. So keep that in mind. Now, one homework for you is you have to ask questions on your own documents. This code will be uploaded in the GitHub and the link will be in the description. So take this code, run it, and use different documents. Do not modify the architecture, only the data source. Also, one more thing, I have also added the GitHub link for the previous video's assignment. So that is also added. Do check it out also. Now in next video, what we are going to do is we are going to see why RAG answers are often bad. Like some RAG answers are very bad. So we will look into chunking strategies, retrieval tuning, and failures. So that will be your next video. Till then, take care and bye.